It is a truth universally acknowledged that a browser tab in possession of a news session must be in want of resource isolation. At least that's how Jane Austen might have approached the art and architecture of secure software design, or how she might have documented the misfortunes of Java and JavaScript, or even written with more sense and sensibility than many internet standards of our day. Which means this week we talk with Aanand Krishnan from Tala Security about protecting data within the browser and what effective boundaries apps can or cannot create therein. In the news segment, Trust and Trustworthiness in Terraform, a dance in 4 steps for supply chain security. Fragmented Wi-Fi conversations lead to misunderstandings, webhooks that speak out of turn, and more. Pour some tea and stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Are you looking for a solution to protect your web apps against the most business-critical security vulnerabilities? Unleash the power of automated ethical hacker knowledge with Detectify for continuous coverage and relevant security vulnerability findings. Upgrade your web app security with speed and scale and start a 2-week free trial at securityweekly.com/Detectify. Go hack yourself. When it comes to web app and API security, the choice is simple. You can choose Fastly's security solution that teams will actually use in full blocking mode, just like 90% of their customers. Or you can stick with costly options that you probably just turn off. You can get Fastly's all-in-one platform that protects apps everywhere they live, however they're built. Or departments can agree to disagree. You can go to securityweekly.com/Fastly to learn more. Or you can just wish you had. For teams looking to inject some security into the DevOps lifecycle, the Uptick Security Analytics platform offers complete security observability for your cloud workloads, including hosts, VMs, containers, and micro VMs. Uptick analyzes builds in development and at runtime for real-time detection of misconfigurations, vulnerabilities, and malicious behavior. Security Weekly listeners can sign up for a free 2-week trial by visiting securityweekly.com/upticks.
This is episode 151, recorded May 17th, 2021. I'm your host, Mike Shima. I'm here with John Kinsella. Hello, John.
Mr. Shima, good afternoon for a change. And we're here with one other special co-host, too.
Indeed. Not only is it a good afternoon to you all, but we also have Matt Alderman. Hello, Matt. You're back.
Happy to be here. I have my tea sans tea. It's the evening. I mean, come on, it's Security Weekly.
This is the high tea, Queen's tea edition of Application Security Weekly. So yes, this is quite proper this afternoon for RSA Week. Other things that are quite proper is that Security Weekly is elated to announce that we will be at InfoSec World 2021, drumroll, in person this October 27th through 29th, 2021. This year, our annual partnership with InfoSec World is extra special, as we are both business partners and, well, business units, I guess is probably the better word there, under the Cyber Risk Alliance brand. What does this mean for Security Weekly listeners and InfoSec World attendees? Well, you will get to see and hear from many of the Security Weekly team at the event, and you will save 20% off on your World Pass. Visit securityweekly.com/ISW2021 to register using our discount code. Do you have a specific guest or topic that you want us to cover on one of the shows? Submit your suggestions for guests by completing the form at securityweekly.com/guests. We check suggestions monthly and we'll reach out to you once reviewed. Aanand Krishnan is the CEO and founder of Tala Security. Prior to Tala, Aanand was most recently a senior director of product manager at Symantec, where he built Symantec's first big data security analytics platform and led key strategy projects that helped establish the company's vision and strategic focus. Aanand spent several years in investment banking and mergers and acquisitions at Morgan Stanley and Dolby Labs, and acted as an advisor to leading security software, semiconductor, and clean tech companies. Hello, Aanand. Thank you for joining us.
Glad to be here. Thank you for having me.
So as I mentioned in the beginning, there's application and security in browsers have a mixed history of security and privacy aspects to them, for that matter. And we've talked a lot on this show of the server-side aspects of this, the OWASP top 10 of SQL injection, cross-site scripting, et cetera, things that rely on server-side input validation or things like that. But we shouldn't forget about what the browser looks like. So maybe just help us kick things off a bit by just understanding what's the difference with third-party risk on the web when we actually start talking about the browser and what's running within the browser.
Yeah, it might be useful to maybe take a step back and tell you a little bit about our journey with Tala. As you mentioned, I was at Symantec, and so were the other founders of Tala, and we spent a lot of time looking at what you would call point-of-sale system skimmers. When people went to shop at the retail store and swipe their credit card, there would be malware either resident in the point-of-sale system or hacked into a third-party vendor. And by virtue of doing that, they would steal your credit cards. And there was a big hack in 2013 at the retailer Target. And we spent a lot of time looking at those hacks because they were all over the place. And we asked ourselves a sort of innocuous question, which is, given that more and more people are shopping online, right? People are no longer shopping in physical stores, at least not for the last 12 months. How would these skimmers operate? People are banking online. Healthcare is moving online. And we said, let's investigate what the modern web looks like. And one of the things, a lot of things came to light when we started investigating the modern web. And one was, as you mentioned, that historically, a lot of the action, if you may, the code execution, the sensitive data, all sat on the server side, right, in the database behind the server. And the browser or the client device itself was sort of just a souped up rendering screen. It was just displaying stuff that was processed on the back end. Google and other companies had a different idea. They said, look, we're going to allow the browser, in the case of Google Chrome, to be able to execute complex web applications. So today, for example, we take for granted that we can edit documents on the browser. We can work with large Excel sheets. These are very powerful applications that you couldn't have done in the browser earlier. Now you can. And the reason that happens is, number one, we have a very JavaScript-centric web. JavaScript is a language that powers the web, and all of that code actually executes on the client side. In addition, because of the need for offline functionality and lots of other cool things that we're now used to, browsers also had to store a lot more information. So one of the biggest shifts that happened was 10 years ago, the browser was kind of uninteresting from an attacker's perspective, right? If I took over the browser, it wasn't particularly interesting. Maybe I could redirect the user to another malicious website and have a kind of drive-by download, but the browser in and of itself wasn't a very exciting place for the attacker. That changed because of all of the things that I just talked about. The second thing we noticed when we looked at the way the modern web is architected is that there is a sprawl of third-party content and code on your modern website. And there's a couple of reasons for that, right? When marketing people wanted to put a tag, a pixel, to understand what customers are doing on their websites, 10 years ago, they had to call the developer team and say, hey, can you put this JavaScript into our website? Right. That all changed because of tag managers from Google and lots of other companies, whereby marketing people, product people, site performance engineering people could change code on the website without ever bothering the developer team. It was essentially outside of the developer lifecycle. And because of that, guess what happened? Marketing teams started adding all kinds of content on the website, so that the average website now uses 3, 4, 5 dozens of these third parties. So that brought us to the obvious conclusion that these skimmers that were operating in the physical world would operate in the web very easily and at scale. And that's kind of been our mission at Tala from day one. There have been, of course, a lot more use cases that have emerged, but we recognize that the browser is an interesting asset for attackers in and of itself. And number two, that there were lots of new vectors of attack, including this kind of third-party JavaScript problem that I just touched the surface of.
Aanand, I want to touch on a point that you mentioned, because I think it's interesting for me. Back when I was building my original startup, we were pushing stuff into JavaScript and doing much more processing on in the browser. Why? Performance. Back then it was performance for us, right? Making that round trip to the server was expensive. So the more I could do at the browser and the more interaction I could do at the browser level, I improved the performance of my application, right? And so we were doing that years ago, but what it sounds like is happening is that same capability has been moved into other applications, and now what you have is an expanded attack surface in the browser because more people are doing things at the client versus at the server level, which moves the attack surface from server side to client side.
Yeah, I mean, the classic example, you must have heard of single page applications, right? Single page application is essentially, a sophisticated way of saying, rather than download an exe file and run it in my device or my Windows operating system, I'm literally going to download all the code in one shot and everything is going to execute at the browser, right? And a lot of companies are now building single page applications. So in some cases, the shift has been very dramatic, but we are still working in a heterogeneous world where the use of JavaScript is very, very preponderous. A lot of modern frameworks like Node.js and Angular, etc., React, they're all built on top of JavaScript. So JavaScript has become the de facto language of the web, and it's good because of all the performance reasons you talked about, but we just haven't historically thought about the browser as an asset to be able to protect because of, number one, the hot potato problem, right? Security people usually said, look, the device, that's not something that I manage, and if it's compromised, it's not my problem, right? And they had a legitimate reason to say that. But when the code that is being sent to the browser is coming from your side or coming from a third party that you brought into the party, then you are actually obliged to make sure that that code doesn't have vulnerabilities, that it hasn't been compromised, and that is not sitting there in the browser stealing my users' credit cards or username and password or registration information or sensitive data or even accessing camera and microphone, right? JavaScript is very powerful. That code can now access all of the stuff that we're doing right now, right? My camera, my microphone, speaker, geolocation, all of this is accessible through JavaScript APIs. And we have no controls, actually even today, on what JavaScript can or cannot do on the browser. If it gets there, it can pretty much do whatever it wants. And that is one of the big challenges that we wanted to solve.
So one of the things that's emerging here is we've got these aspects of the growing attack surface of just the HTML, the DOM and the DOM APIs, access into everything from there have been specs for getting HTML into Bluetooth accessories, which hopefully isn't going to go anywhere, but also Bluetooth HTML access to many APIs, whether it's power management to other things. But where I'm going with that is that sense of fingerprinting the client or gleaning information about the client, as well as just everything you've been describing about these broadening attack surfaces and these more sophisticated and growing sophistication of apps are really just constrained for the most part within that same origin policy within browsers. But same origin policy quickly became insufficient to protect users, to protect security and privacy. So we started to see things like content security policy, iframe sandboxing, even things like more refined referrer policies to help prevent some of the information leaks. But even just starting with CSP, as I rattled off that list, it's a great tool in theory, but I don't know that it's great in practice. How have you seen some of these tools that are there for helping that client-side developers protect their DOM, protect that same origin from being successfully adopted, or what are the ways that they can try and tamp down or can gain control over this attack surface within the browser?
Yeah, I think the good thing, and I think the best thing that Google and many of their peers did is that not only did they architect this kind of modern web, if you may, with a very powerful browser, they also recognized that you needed better security controls at the browser level. They wanted to protect their own applications like Google Docs or Gmail and whatnot. And so they came out with a lot of homegrown security controls, one of which is, of course, content security policy, which is a very powerful mechanism to be able to restrict what can happen within the browser. So if you implement CSP, as it's called, accurately, the browser is essentially restricting what kind of behaviors JavaScript can or cannot do at the browser. So, for example, a website protected by CSP will block domains that are not part of the allowed list of that website. So you can say, look, these are the only list of domains that can serve JavaScript into the browser. These are the only domains that can serve images or style sheets or accept form data. These are the only domains to which you can make WebSocket connections or XML requests. So there's a whole set of behaviors that developers can create a whitelist, or now what we call allowed list for, and send that to the browser, and the browsers will understand it. All of the browsers understand it because these are W3C standards, and implement essentially real-time protection at the browser. The browser itself acts as a security control point or a security mechanism. The issue with this in the practical realm is that, except for companies like Google, who do have very sophisticated security teams who understand these technologies very well, other companies by and large have struggled to implement these security controls. And there are lots of them, actually. CSP is very important. You touched upon referrer policies. There is now something called permission policy that allows you to control who has access to, which JavaScript can access my camera or my microphone, for example, or geolocation. There is a technology called sub-resource integrity that allow you to essentially do a kind of lightweight code integrity check at the browser level. You can actually send a SHA hash value with your JavaScript file, and that'll ensure that the browser doesn't execute a JavaScript file that has been tampered with. So we've seen, for example, in the real world, lots of attacks, groups like MageCart that have been hacking websites and stealing credit cards. And what they do is that they go to a third-party JavaScript source and compromise it. And that compromised JavaScript code hits the client, siphons off the credit card data. You can prevent all of this with these technologies. There's actually more, like iframe sandboxing. Google is coming out with new technologies like trusted types to prevent DOM-based cross-site scripting. So the good news for developers and web application security teams is there are lots of tools available, but the bad news is that they're actually quite difficult to manage. And they're difficult to manage, number one, because somebody has to create the policy. A lot of time, the developers only know the code that they are deploying. They don't necessarily have a view into what third-party JavaScripts are being used, because all of that is coming straight from the marketing teams. And the marketing teams, they really don't care about security, right? That's the reality. Product teams, they don't really care that much about security. So you have this fundamental question of who is going to create policies? Who is going to decide whether Google Analytics should be allowed or not on this website, right? It's a very non-trivial people problem. Number two, websites are very dynamic, right? Web applications are super dynamic. Some of them change every week. A lot of them try to change it every way. You have this continuous delivery model these days. So somebody has to actually update these policies. And that, again, becomes problematic. And even if you achieve both of these, which are difficult, somebody has to actually make sense of all of the alerts that come back. One of the most powerful aspects of these technologies is that if there's a violation, if there is malicious code or anomalous behavior of the browser will actually report to a self-declared, or sorry, a declared endpoint that, hey, I'm seeing some anomalous behavior. That's wonderful if you want visibility at the browser. It's bad if you're a security person who already is dealing with a deluge of security alerts, and you're like, okay, now I'm getting another 1 million alerts per day from my browser, from my browsers. What am I going to do with all those? And if you don't do something with that, you really haven't solved any problem. So soup to nuts, it's actually a difficult problem to automate, difficult problem to execute and maintain at the enterprise level. And it was pretty clear to us as Intala that this problem had to be automated. And so we recognized very, very early on that this problem was ripe for automation. And the good news is that there are some other vendors out there like us who are helping companies automate the implementation of these standard-based security controls. So what I would recommend is, and we've seen this a lot, that companies try to do it themselves, they fail, and then they come to us. So there are lots of options out there. I think we're a great option, but there are others. And I would certainly recommend enterprises to try not to just wing it, but actually do this seriously.
So I want to explore a little bit more just what of the some of the threat models are around this, because one of the with modern applications, CDNs are used everywhere, and you were kind of alluding to this a little bit, like with a mage cart type of strategy that says rather than try to compromise the servers where the HTML is being served from, the organization's own servers, go for the CDNs perhaps, or try to infect a different part of that supply chain. So it's sort of a supply chain for the client side JavaScript, if you will. Things like the sub-resource integrity, just taking that SHA hash of the content, can help say, oops, this can help detect that this has been tampered with and can just reject that and protect the browsers. The catch there is that for many dev teams and even marketing teams that do care about security, that it's kind of hard to figure out how do we make sure that if this JavaScript library that we're loading changed because of a legitimate reason, because they can change quite a bit, or it can be just a single line like JavaScript loader, and so you're taking a SHA hash of some JavaScript that's loading some other JavaScript that you don't have a SHA-1 or a SHA-256 hash for, in this sub-resource integrity type of approach. So I'm kind of curious, help us learn a little bit more, either sort of what can be protected with these types of defenses, or how should we make sure we're aware of what the security boundaries are of what's being, what are the difficulties in getting these deployed properly in the first place?
Yeah, it's a very good question. And I think you started by alluding to the different attack vectors, right? At a high level, groups like MageCart, who've been operational for the last 4 or 5 years, what they have done typically is identify a weak point in your software supply chain for the web. Identify a company that is serving JavaScript to the browser that doesn't have the greatest defenses, hack into their code, tamper with their code. So it's actually coming from the same domain that it used to. It's so that the browser doesn't necessarily recognize that something is amiss, except that now that code has additional JavaScript that will siphon off all of that data to a command and control server, right? So what happens in these circumstances is that the user and the owner of the website doesn't know that these attacks are happening, because the transaction is going through, right? People are being able to purchase what they want, except a copy of the credit card has now gone to the attacker. In these kinds of cases, we recognize that the best thing to do at the browser layer is to create a model for what is allowed and what's not allowed. So for example, you can restrict domains from certain types of activity, right? You can essentially say, look, if you're Google Analytics, you are allowed to do activities A, B, and C. You're allowed to send JavaScript, you're allowed to, send images maybe, but you're not allowed to collect information. And maybe you can do that on a specific page and say on the checkout page, I don't want Google to be able to collect information. So really, it starts with understanding your application and understanding especially the data exchanges that are happening from the browser out to the external world, and then being able to say, look, on this checkout page, I only want my credit card information to go here, to this particular domain. And that means that you're not only going to want to deal with CSP, but also with sub-resource integrity and pretty much all of these security controls you have to give yourself the best shot at being able to protect against anomalous activity. Ultimately, all of this manifests itself at the browser as anomalous behavior, either scripts being loaded from the wrong domains or scripts being loaded from the right domains that are exhibiting behaviors that we were not expecting or we didn't see before. So if you have a sense of anomalous detection, you can detect and catch it.
Yeah, and that's what was kind of a path I was going down as well, is in the sense of someone, if someone can have access to the server itself, change the content, that's one thing. But there's also situations where marketing apps are just tracking pixels, or we've also seen instances of legitimate tools used for metrics, analytics of user behavior and user tracking on web applications. And these are things that will do everything from mouse tracking to basically keyboard interception. And so from a security perspective, perhaps there is a desire to have these types of user behavior analytics within the client side on the JavaScript, but you'd want to make sure that there's, how much confidence can you say that these third-party apps aren't able to look at the password field for login credentials, or they're not able to exfiltrate that data from that password field to an unapproved third party. So I think this is another thing. You start to get into some nuances of what are the scripts that you're running, and answer that question: do we want to run these scripts in the first place? And if the answer is yes, figure out how can we actually restrict it so we know either these are some behaviors that we have approved explicitly and everything else is forbidden. And I think that's what we're kind of getting at here with this idea of CSP, sub-resource integrity, even iframe sandboxing, to help us basically get more granular access on this same origin policy that's been pretty creaky over the years.
That's right, and I think it's actually very easy for the developers to make a simple mistake and end up with a keylogger, right? Developers are under a lot of pressure to deliver new code. Sometimes they get product requirements that are not well defined by the product teams. They end up creating code that are maybe collecting information that really they shouldn't be collecting, right? And I think privacy is a very, very important aspect to all of this, which has made the browser such an important asset, right? Because if you really think about sensitive information about users that enterprises have, a lot of this is coming from websites. When the user goes to the websites, websites are tracking what kind of products are they looking for, what are their behaviors, how much time are they spending. There's a contact form where you send, where you input your email address, and that goes into a marketing platform, and eventually you get a lot of spam, right? So essentially, websites are the most important asset, I would say, in terms of sensitive data collection, and we are clearly inside the privacy era. And I think one of the things that we are lacking today as an industry is visibility, data inventorying, data mapping, data discovery, as well as third-party access at the browser layer. So if you really don't have visibility into what your performance monitoring tools or your analytics tools or your marketing or your ad tools are doing on the browser, there's no way for you to provide any real privacy guarantees, right? Like, for example, we have cookie preference on almost every website today. You have cookie consent banners, right? You go to a website and it says, on my website, do you want me to drop strictly necessary cookies, or can I drop other cookies, right? And you make some preferential choice, and then that goes into a black hole. There is no mechanism today for websites to actually guarantee and honor that, or make sure that they're actually honoring that user preference, that they're not dropping cookies that they're not supposed to. They don't have a mechanism to be able to stop a cookie that shouldn't be dropped from executing it or being ending up with the browser. So we have fundamental privacy challenges at the web layer, at the browser layer, and we're seeing this convergence between security and privacy. And I think what's going to happen is a lot of the work that people are doing around protecting the browser against malicious code, third-party content, third-party code, unauthorized behaviors is eventually going to help us get much better at identifying privacy issues, alerting privacy teams against privacy issues, and ultimately providing data governance. So I think one of the things that I'm really excited about is the kind of things that we can do not only on the security side of the house, but also on the privacy and compliance side, because of the importance of the browser for data collection.
Aanand, I want to talk about cookies in two components. There's been a lot of talk about limitations of third-party cookies going forward, where you can only have first-party cookies, and the marketing teams are like freaking out because they don't know what to do, and that's a whole separate side channel. But if we get to the point where we start dropping third-party cookies, and it's only first-party cookies, that potentially gives us a better privacy mechanism in place. But my question then goes into this whole thing around policy, right? Having been on the governance, risk management, compliance side, and having built manual policies and try to enforce policies, how do you continually monitor and update your policy requirements in the browser so that you're enforcing the right policies, whether you allow third-party cookies, you don't allow third-party cookies, or any other policy aspects? Because I think if you can find a way to dynamically change those policies on the fly, we get ahead of the game versus what we've traditionally done is, well, here's our policy, but at any time a code release happens, how do I know that that policy is still valid?
You're right, exactly. I think number one, and I think there are some tips. Number one, you have to integrate it into the CI/CD or the life cycle of code development. It has to be that the policies are generated or a byproduct of the development process, right? Somebody's making new changes, and at the end of that, there has to be a new policy that gets automatically generated and is ready to go into production. The second problem, I think, that it's ultimately a people problem is, there are at least 3 or 4 stakeholders that tend to change the code on the website. One is obviously the developer team itself, but you also have site performance and site reliability teams, product teams, and of course the marketing teams. And there has to be, I think, really a process by which whenever, for example, the marketing team makes a change, that security can, ahead of time or before that tag is getting added, have the ability to weigh in on whether this tag that the marketing team is adding to my website, is it something that I would recommend? Is it a service that a lot of people use, or is it a no-name service that could potentially be malicious, right? So one of the biggest challenges with all of this is, number one, as you pointed out, having a mechanism by which at the end of the release cycle or just before it goes into production, the policy is essentially ready to go, or at least in a state where it can be fine-tuned in production very quickly. And number two, having the process within these multiple groups, security, marketing, developers, product, etc., such that any changes are being documented and approved in the right way. Today, those approval processes don't exist, which is why what happens is that you may have a marketing person who goes in and adds dozens and dozens of third parties. They leave the organization, and then the next day, security teams are looking at the website and they don't know why there are all these tags and what they're doing and who signed up for them. So people and processes are very important. And number two, having this automation so that policies are automatically available at the end of the build process.
So I want to double check that last minute or so there, what you're just saying, because it makes sense to me with my security hat on. But at the same time, we're DevSecOps. We're here talking week after week about getting security into the development process. And I say that, I put that in as a preface to sort of say, we, the security people, are frequently the last people that the developers want to see. Right? We usually slow things down. We make things more expensive, blah, 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 blah. And it's just for security, in quotes. So the way I heard what you were just saying, I want to sort of comment on a little more, is you want security to get involved in marketing. Is that an accurate translation? Do you see where I can see a lot of people going, that we're not down for that. So talk a little more about how you see that actually working.
Yeah, that will practically never work, right? I think what is missing today is, if I'm a marketing person and I want to make a change to my website, security is completely out of the loop of that. We speak to enterprises all day long, and I cannot think of many enterprises who really know what's running on their website. The security teams simply don't know because they're not in the loop at all, right? Marketing teams can go and make changes to the tag manager and add whatever pixels or third-party tags that they want, unbeknownst to the security team. So what I'm suggesting is that, and this is what we implement, is a process by which, if the marketing person wants to make a change to the website, that security has the opportunity to either weigh in before the fact or after the fact, right? Enterprises can go either way. And for example, let's say that I'm a marketing person and I'm adding Google Analytics to my website. Security teams need to be notified that there has been a change made. Even that doesn't exist today, right? So security teams need to know, okay, on this flagship mission critical web application, somebody's added third-party code. Okay, where is the third-party code coming from? And have the ability to say, look, yeah, this is a reputed service. It's not collecting data that it's not supposed to be doing. I'm blessing it, so let's continue. No issues. Or be able to say, look, this is a no-name service that I've never heard of. Thank you, marketing, but I'm, from a security perspective, I'm simply not going to let this happen because there's too much at risk here. And I think historically, marketing had complete control over that, and I think security needs to wrest a little bit of that control. So, while it might look like it will add a lot of friction, I think if it's done well, both marketing and security win in the process. So, I don't imagine that security will ever weigh in on marketing decisions, but there are many cases where today security simply doesn't have any visibility into what marketing is doing. And I think that's, we all recognize that that's one of the fundamental reasons we have this problem, because there's a lot of third-party code, and all of the third-party code is coming from marketing teams adding them willy-nilly. And it's important for businesses to continue to do that, but there has to be a level of checks and balances before this happens and it gets out of hand. Right?
Yeah. So really, it sounds
like. Oh, go ahead.
Oh, just really briefly, it sounds like the trick there is to make that, I'll say alerting, but that monitoring process to happen in such a way which is really without any, come on, John, without any type of restrictions for the marketing people. So almost without them seeing it is what you're sort of hinting at.
Don't create friction in the process, just like we don't want to do with the DevOps teams on the marketing teams. But if we can give them a dynamic way to identify where potential malicious third-party content is, then let's make sure we try to fix it, right?
Or just the governance aspect, which is the fundamental aspect of just what are we running, just an asset inventory. We know the asset inventory of what our own developers are writing, but what's also on the client side in terms of domains we're loading resources from, and then potentially domains that we're dropping cookies onto, or in the sense of tracking pixels, domains that we are I'll use the term deliberately, exfiltrating information out of the browser to third parties. And I think that aspect, just knowing what is present on that website, rather than having someone load it up in their browser and having the browser report back, being able to do that more proactively and at scale for your own organization does sound like an important need, considering all the different ways that this type of code can show up there.
Yeah, one last point I would say is, even though it's a little bit counterintuitive, what we have seen is that when companies implement these security controls properly, not only are they protecting the browser against attacks, or inadvertent or malicious data exfiltration, they're also removing a lot of the performance degradations, like, for example, redirections, competitor ads, nuisances that actually degrade customer experience. So many companies, they'll tell you that after implementing these policies, they might see even an uptick in conversion rates on the web, because there's just less junk being injected into the browser. For example, browser extensions, right? People have all kinds of browser extensions installed on their browsers, and they oftentimes interfere with your website. That's what they're there for. So a well-crafted policy can actually protect the customer experience, which actually has a positive impact on the business. And I think that's an angle that we haven't talked about, but it's important to keep in mind. So there's actually benefits to product and marketing teams from doing these security controls and putting them in place.
Well, Anand, we had a well-crafted half-hour chance to speak with you on this topic. I want to say thank you for joining us.
No, thank you for having me. I appreciate being here.
Yeah, this was some good insights on protecting the clients, protecting the browser. And we also had, of course, joining us, Matt Alderman. Welcome back for a bit, Matt, and John Kinsella. And want to thank everybody for listening. To learn more about Talos Security, visit securityweekly.com/Talos Security. We're going to take a quick break now and return with news of the week.